and welcome to the podcast. I'm Dan Linstedt.
And I'm Sanjay Pande.
And today we're going to talk about data vault and data science synergies. So specifically, how data vault enables data science and how data vault uses data science. And of course, we're going to talk about the business benefits that data vault brings to the process of data science. So Sanjay, what are some of the synergies you've seen between data vault and data science?
So this is actually a huge topic. We could probably write a book on it, honestly. I think the first aspect that I'd look at is, I think Cindy put it very aptly, data science programmers who would be very valuable as a data science resource are not really data engineering resources. So they would be the most expensive data engineering resources on your team. And it would only make sense that you actually have a data engineering team deliver whatever they require to them, because they are a consumer of the data. They're also a producer of the data, but essentially they're a consumer of the data to add business value to the organization. And Data Vault is set out in a way that we can flexibly design outputs and outcomes to what we call information marts and give that to the data science teams. So that would be like the first synergy that I see, where the Data Vault itself, as a team, the data engineering team that uses the Data Vault, can deliver whatever the data science teams will consume and build their data science results from there. Now, another very interesting one is where it goes the other way around, where we actually use data science in the Data Vault 2.0 system. So one of the very new and interesting things that happened with Data Vault 2.0 was something called an exploration link. Now, exploration links are, they belong in the Business Vault area because they are outcomes of data science. And because of their data science results, they can't be replicated from an auditable perspective, but they're extremely useful from a business perspective. So it's something where we can actually use a data vault in a situation where the outcomes from data science results help drive the business. And I believe there is a company called Netcode, which we'll get to. There's a lovely example that I'm going to get Dan to elaborate on. But the exploration link doesn't just stop on the example that Dan's going to talk about. If you think about exploration links, think about you have business keys across the enterprise, but you don't actually have a defined relationship with them anywhere. The only way is either to ask a human being or a machine to find that out. And that's also where exploration links can actually help out figuring out relationships across business keys where you don't actually know what's happening. And of course, because it's not auditable, it goes in the Business Vault, which is a standard. And there's a lot more we can do there in terms of leveraging data science. One of the things about data science is you produce these results and you have these estimates and weightages. And data science is always built on a model of, a learning data set and then an analytical data set and then an outcomes. So you have to split the data into what the systems would learn. And then, you apply that to a test set and then you predict using that. Now, what Data Vault gives the data science teams is a structure and a framework for temporal archiving of each data science result. So what they can archive their results by date. And what that does is when you use the data science outcomes, you don't actually have the results yet. You can have the data science results, but we don't have the actual physical results that the business actually saw after applying all these data science rules. But if you archive the results, you can, when the actual outcomes happen in the business, you can compare that to the outcomes of the data science, and you can tune and improve your data science to become, better and better and better and better over time.
Well, you mentioned exploration link. I just want to talk about that for a second. And from the exploration link perspective, I really want the people to understand that this is an object in the database that is built based on the concepts that Bill Inman wrote about in his book, Exploration Data Warehousing. And I really think from a business perspective, business folks should go back and read that book. There are a number of key concepts in there that are just groundbreaking, from my opinion. You want to explore the data for sure by storing it in a link structure in the Data Vault or in the warehouse, you can save the iterations, right? So you can see whether or not the decision you're making makes the outcomes better or worse. And that's an interesting metric to look at. So if you look at the evolution of the results in an exploration link, which is where you would put the data science results as well as future predictions in an exploration link, then you would have grounds to be able to watch not only the data set evolve from what goes into the data science algorithms, but what comes out of the data science algorithm. So I think the exploration link can be used in a multitude of purposes. First and foremost, it can be used on the raw data by the data analysts themselves, or by the BI folks, or even by the IT folks, to build a set of flattened predictive data sets. And what I'm saying there is you can add metrics. It's in the business vault. You can add specific computations and algorithms and means and medians, maxes, and all kinds of wonderful things. So you've got the predictive analysis going on. Then if you run it with the temporal archiving and you look at the retrospective, you can see the results evolve over time. And the example that we're going to get into here in a minute on Netcode talks about some of these aspects of utilization. Sanjay, do you have any other thoughts on the temporal archiving of data science results? You've done some data science in your past. What does this mean for the business?
The point I did want to make is how analytics has evolved in terms of, there's a lot of stuff that has been around, but now it comes under the gamut of analytics. So the way it used to be defined is basically your canned reports, what happened, and then you had your diagnostic texts, like, why did this happen in the company, right? And then you would take action. And then before today, it was predictive analytics. And even today, predictive analytics is a big thing. And it follows that structure that I talked about, right? With test data and the learning data, test data, and then the predictive outcomes. But what's new today is what is called prescriptive analytics. If I do this, what will happen? It's a more complicated question. And that requires tuning over time and verifying what you've tuned and your models with the data set over time. So without actually storing and leveraging this data over time, which is naturally stored in a data archiving area like a data vault, it would be impossible to do that with the confidence levels. You can do it. It just can't track it in terms of, with a high confidence that this is the way to do it. So I would highly recommend that it be done like that, so that you tune your data science processes and you tune the interaction between what we would maybe call the analytics teams and the data science teams. And over a period of time, I honestly think these two teams should eventually merge. That's my opinion. I think they actually belong in the same space. And it's really nice to see from a data vault architecture perspective that we've already thought about these things. We even teach it in the trainings in terms of how data science and DV teams get on with each other and help each other out. From that perspective, I think we should get into an example like the Netcode. I think that's a really interesting example on how a company actually benefited from utilizing data science on data vault construct. Dan, you want to elaborate on that example?
Yeah, absolutely. There's a couple of things that are interesting about that. The first is that this was done in the mid 2000s. So this was quite a while ago, maybe a little later, 2008, but Netcode is now gone. They got bought out by a bigger company, and I'm not sure who or where, but anyhow, Netcode was based in Denver, and I lived in Denver at the time. When I went in to help them, they were an organization of around 50 people. Their IT team was around 12 and included a couple of data scientists, 2 or 3. Data mining, they specialized in back then is what we called it, right? AI and ML and data mining techniques. And what they built, the first thing that was interesting was they built an operational data vault. We talked a little bit about this, I think, in the last podcast or one of the previous podcasts. And what I mean by operational data vault for a business person that's listening is basically they built their operational system on top of data vault methodology, modeling, constructs, architecture. It was all one and the same. So the database that handled all of the operational system was on top of a data vault. So there was no ETL or ELT. There was no staging area. There was no need to move the data. It was all real time. directly in and out of the operational data vault. So that led to a really interesting case. Their business was being an insurance quote brokerage. So they provided insurance quotes as a service, as a brokerage service for different insurance agencies in the United States. And so they were regulated by the United States regulations, which differ from state to state. So there are different offers that can be made depending on which state you're going to. And back then it was difficult. If you were a citizen and you were moving from one state to another, it was difficult for you to find insurance, health insurance, car insurance, home insurance, auto insurance, whatever. Difficult for you to find an insurance plan until after you got into that state. And it was even more difficult to get some sort of estimated quote in terms of living expenses and what it might be because of the state regulations, the different state regulations. The insurance companies were not allowed to sell their insurance outside of the state. So along came a broker that said, well, if we do this progressively, we can negotiate because we're on the web. And back then, of course, the web was a little bit more free than it is now in those terms. If they negotiated, and what they did was they negotiated with big insurance companies who knew the state regulations. And they said, well, when we're going to present offers to people that hit our web service that are looking for quotes, and most of these people are before they move right into another state, or competitive quotes. In some cases, that's the other thing they offered, is competitive quotes within the state that you lived in. So one of their metrics for Netquote for success at the business level was, how long does someone spend on our site? And it turns out, you would think from that question that the longer someone spends on the site, the more likely they are to spend money. Wrong. In the case of insurance, that's dead wrong. In the case of insurance, the shortest amount of time is the most amount of profit for an insurance quoting company. And how did they get to that result? How did they understand this? How did they figure that out? Well, they used an operational data vault, and they used that in combination with live or real-time data science or real-time data mining. Now, they were in a very vertical model in the industry. So they didn't span all kinds of industries. Their data vault system or solution had about maybe, 30 tables or so underneath a web app. And that was all web app driven. That was their operational system, basically. When we started, they first started by saying, when you hit the homepage as a guest, we need to understand what you're looking for. And the further down, they thought the further down the page you scroll, the more interested you are. And it turns out that was wrong too. The further down the page you scroll, the more confused you are. And that was interesting. And the less likely you are to stay on the Netquote site or even respond to an offer. So they started out with this pitch. Data science and the numbers revealed that if you scroll down further in the page, you get better offers. That's where they started. But it also was turnaround time for the offer. They spent, it might be 2 minutes in the beginning before you saw an offer as a guest on the website. But in order to take advantage of this offer, you had to click through it, and then you might have to add your email. And then if you want to know more about the offer, it would be an offer range, 10% to 25%. We can't nail it down for you until you tell us what state or what area you're moving into or what state you live in. So they could pick up, after email, they could pick up address information. And then there was risk associated with the offer, right? You don't want to offer a 20 or 30% discount from insurance if the person has known to be high risk and they're just shopping around. So there has to be some communication of private information coming from the insurance company. But in order to do that, you have to identify the individual. Right. So there's a lot going on in the background in these 2 to 5 minute spans of hitting the Netquote website. From a business perspective, they thought, well, if your first offer appears within 20 seconds, you're more apt to click. And what they needed to do was reduce that click time, that first offer time, from 20 seconds to 3 seconds. And the only way they could do that is through something called the exploration link. And so we built this exploration link, and we stored 6 months worth of explorative data. We captured 6 months worth of data, running the old algorithms, producing 20-second ad turnarounds and so on and so forth. And we then re-examined and remined the metrics. And then we rebuilt the model. And by adding another exploration link, we were able to reduce the time. And of course, there was a brand new model using a feedback loop. I think they used an ANN neural net. And they used another kind of neural net as well, which I forget, which has strength and confidence ratings, in its decision-making process. Basically, it was a decision tree type of neural net, and it had a strength rating in the table, and it had a confidence rating, how confident, if you took this path through the website, if you stayed on this page for XYZ, you were, quote unquote, this type of customer. And every time you changed pages, there was another form that asked you for a little bit more information. So it was really form driven. Go from I'm a guest to here's my email, from here's an email, I'm interested in these offers, I want to know more, to give us your first and last name and your current address so we can look up and potentially where you're moving to. And then it went from there to, I think there were 2 more forms after that that got more detailed around whether you wanted home, auto, life, car, because obviously you could bundle more things and get a bigger discount offer. So all of that was in the works, but it was built into this exploration, quote, table, and data science or real-time data mining was driving it. And the end result was the guest got their first offer within 2 seconds. So a 20-second time frame from hitting the website to getting an offer was reduced to 2 seconds. And instead of scrolling down the page to get the best offer, they got the best offer in the first 2-3 paragraphs at the top of the page without scrolling at all. And if someone scrolled further, what they did was they actually popped up something different, not an offer. They popped up a live contact to an agent and said, we see you're a little confused, or something to that effect. Do you want to talk with someone live? Right. So they changed the nature of the site and what they were offering. And their revenues, after doing this, their revenues tripled in 6 months. I think I can't remember exactly the numbers, so forgive me, I'm going to get them wrong. It was something like went from a $30 million a year company to a triple that, a 90 or $120 million a year company. And that happened in 6 months. And then, of course, they got bought out. Right after that, they got bought out. Well, who wouldn't buy them? The revenue projections were through the roof, and their overhead costs were extremely low because they only had one operational system and they had 50 people working for them and 12 people on IT staff. So they were a very mobile company and very, very quick. They weren't big. They didn't have all the bureaucracy and so on. And they did so well in their buyout that I got invited to their company party on the buyout at the Mexican restaurant down the street from them. So, that was kind of cool. I didn't get any bonus based on the revenue that they got from the exploration link and some of their efforts, but I certainly helped them with that. So that's sort of how the story goes. And this is what involving data science in the IT team and in data warehousing did for Netcode.
What I like about that is I was listening to the story and I'm like, it's not just one way. I mean, it's like I can see where they would have leveraged the data vault as well to store the results, just like we were talking about, so that they could improve their algorithms and ensure that their outcomes are better and better over time. It's also really interesting to note buyouts, right, with these companies doing data vaults. And it's like, I mean, investors should start paying attention to Data Vault 2.0, in my opinion, based on these buyouts happening. It's like a company doing Data Vault is like they make a lot of money and then they get bought out. That's not a uncommon story.
Yeah, well, Sendent Timeshare Resource Group was the first one we spoke of a couple of podcasts ago, and they got bought out as a result of that, doing an operational data vault. And then now Netcode did the same thing and got bought out. They asked me the same question. They didn't know about Sendent, that they asked me the same question: can we use data vault in an operational system? And I said, sure. So we built the team, and it was a small team. It was 12 people, including 2 or 3 data scientists. We had 1 enterprise data architect. We had 2 or 3, business analysts, and just on and on and on.
What's really interesting as an observation is how well the Data Vault 2.0 system enables small teams, but it also lets you manage humongous teams. because it treats everything as like you can treat everything as a small chunk, right, inside the big whole, and still look at the overall picture. Kind of like everything in the architecture, like it's almost like Lego blocks for every part of the architecture, whether it's the teams of people, whether it's the structures within the database. Everything is designed like that, and how it has become that way. What is really interesting is coming back to two examples being operational data vaults, how much easier it is to do today compared to how it was before. I mean, it's just far easier now, isn't it?
Yeah, it is. If you have a good team that understands operational system programming and that understands operational system like GUI app design, and there are tools that automate and assist and enable acceleration of building apps in a consistent manner. And so definitely leverage those. But the difference is those apps that build that, they build traditional 3NF, third normal form data structures, and they don't know about data vault, and that's where the disconnect is. So when you build a third normal form structure, you're getting yourself, even in an operational system, you're getting yourself into this never-ending re-engineering cycle when you want to change, and that's not a good place to be. Whereas the operational data vault applications that were built using DB2 didn't suffer the re-engineering fates. They could grow, they could change, they could morph as the business does at the speed of business. And they did, both of these companies that I mentioned, did have to write their own operational application because the builders and the accelerators they connected it with the third normal form stuff and not the data vault stuff. But so they wrote their own layers. It's fairly simple. It's not that difficult to do, but you have to have knowledge in data vault in order to get it done right. But the business benefits are tremendous, absolutely tremendous. Now, one other thing I want to point out, both of these organizations were fairly small. They were not global organizations, okay? They were not hundreds of thousands of people. That's not to say you can't get value out of operational data vault in a global enterprise. Heck, it was built inside Lockheed, which was a global enterprise, and you can get value. What I'm getting at here is something else called scope of the project. Start small, never boil the ocean. You've heard this before as a business person. Never boil the ocean. Always start small and create lots of small successes rapidly. So if you can take your scope at a business level and say, I want this to be operational data vault, just this vertical chunk or a vertical slice, and can we get it done in 2 months or 3 months and out the door, finished, and in production, maybe in less time, maybe in 1 month, if you're lucky, if you've got good solid people and resources, then that's what you need to build, because right after that success, you can choose another vertical chunk. The way the data vault is architected and the way the DB2 solution allows is pattern-based and repeatable across the board, whether it's incremental team builds or whether it's adding to the architecture. And again, without re-engineering the solution you just finished.
That's cool. I'd like to do a thought experiment here. I see a lot of synergies, again, between what would be called application teams who are used to building agile stuff and our data vault teams who are trained on doing the data vault style agile. I mean, if we can combine these two somehow, whether these guys train on data vault or whether these guys take up projects for designing the database side and the other side for the application guys, I think there is a big potential there.
There is big potential. If there's any smoke and mirrors, which there really aren't, if there's any magic pixie dust, which again, there isn't, it would have to be in something called the data access layer. I've mentioned this before. The data access layer allows the application to, quote unquote, see or use or think it's using a traditional database model or third normal form or whatever, normalized structures. When in fact it's using, under the covers, it's been translated into using the data vault structures and the data vault method and the data vault modeling and methodology. It's a very thin layer. It's really comprised of views and an access locking mechanism. So if the operational programmers understand how to select data for update or begin transaction and then lock a record and do what they need to do and then commit or roll back at the end of it, then they're good to go. And there's only one other piece really to this puzzle, is that we never ever issue an update statement. We always run the delta in the data access layer and say, is the new record that's going to be updated a delta? And if so, then we turn around and insert it as a new record and supersede creating this audit trail history in the warehouse context, supersede the old record. So that's how that works. It's extremely simple from a business perspective, even from a technical perspective. Honestly, we can help your company get there rapidly.
I mean, all that stuff is baked into the architecture anyway, so that's the best part about it. You take training and you know how to do it. And interestingly, now, like, for example, Snowflake, with their new storage format called Unistor, where you can, it's designed now for both transactional with relational integrity, referential integrity, with commits, and the query, analytical query, and a transactional query going against the same storage. So they're actually designing systems to take care of this. Like it's already coming, and it can get taken advantage of with the Data Vault 2.0 system of business intelligence.
It really can. It really can. And I just have a closing comment on that bit. Back in 2002, 2001, when I did one of my first presentations at TDWI on Data Vault, and I used to teach in the US circuit every quarter. I think I taught from 2001 to 2005 or 7 or whatever it was, but many years. But one of the diagrams and I'm ashamed to show the diagram today. It's basically two very narrow or thin triangles, and they're endpoints. It shows on one end, on the left side, it shows divergence of operational systems and data warehousing or business analytics. And that's where we started in the 60s and 70s, because the operational quote unquote technology couldn't handle the needs or demands of the business analytics, right? So they diverged. And on this diagram, I predicted in 2001, 2002. And now I'm not the only one to predict this. There were others at the time also saying this would happen. Then I had 2 points. I brought them back to the right-hand side in a singularity. Now in my diagram, they never met, right? They never got back to zero. But it looks like with the Snowflake innovation, they actually came back together. So you can do exactly that. You can put your analytics and your operational systems in the same place at the same time. If you leverage DV 2.0 for this purpose and for operational data warehousing, if you will, or operational data vault, you've got even more power. So I think the sky's the limit, as they say, and it really can go just about anywhere you want it to.
Yeah, their technology is still in beta. They're still testing it out with customers and stuff. But it's one of those things, right, where technology actually is catching up with concepts, and I would say catching up with Data Vault in some way. I'd like to say that. I think that's pretty much time for today. Is there anything else you want to add, or?
I think we've bored the audience to tears today. So if you're still listening, thank you very much. I'm Dan Linstedt.
Okay. And I'm Sanjay Pande.
We will see you next time. Take care.